Okay, let's start. So welcome everyone. This is the community meeting for OpenFGA April 2024. This means that we already went through 1/4 of the year, which is pretty awesome and fast as usual. And so hopefully you all get to complete your Q1 goals or whatever you're working on. So congratulations for that. And let's see what we are going to do today. So we always have the same structure for the meetings. We kind of do short introductions, particularly for the people who are new to the meetings and they want to explain a little why they are here and what they're looking for in OpenFGA. We just talk about some features we shipped, we do some demos, we discuss about current and future work, some community news, and then some QA. Today we're going to have a few demos that will be from the team, and then we have Massi, Gori from Canonical, who also going to walk us through how Canonical is using OpenFGA, which is going to be very exciting for us too. We're going to learn a lot there too. And so this is the OpenFGA team. We kind of, if you've been following us, we kind of the team grew a little in the last few months, which is great. So the flags and the right are where we live or where we were born, depending, or both, depending of each person, they can pick which flags they want. And so if you want to spend, we're going to spend like a few minutes for everyone who wants to introduce themselves to do it. And so I will kind of do some silence and give you some space to introduce yourself if you want. And so that will be now.
Okay, as introduced, I am Joaquin Salvatruba. I'm from Technical University of Madrid, and we are doing research on data spaces, Gaia X, and all these kind of things of interchanging data under sovereignty. And we need data access control and these kind of things, and we are going to use of OpenFGA for this. We will link to WCC ODRL, the language for defining policies, and we want to make some mix. And even if it's not so complex, we need to connect all this with self-sovereign identity, with IDs, and all this kind of stuff. This is our plans and on this.
Cool. Thank you very much, Joaquin. Anyone else wants to introduce themselves? Okay, good. Let's move forward. So my expectation was that we were going to already have shipped modular models today. It's going to happen probably tomorrow or after tomorrow. And we're going to demo it with the current state of the feature, but and what the problem is trying to solve. And so right now it's an experimental flag in the latest version of OpenFGA, which is 1.5.2. And it will be released later this week. And so hopefully, if you have scenarios where you have like a larger teams or multiple teams collaborating on FGA, you're going to find it very, very useful. And we also completed an integration with Java Spring that we demoed in the last meeting, and that is available already in the OpenFGA organization, so you can take a look at that and provide us feedback. We won't be demoing it today, but it's already public. But we're going to start, given we have a guest today, which is Massi Gori from Canonical. I'm going to ask him to start with this presentation. So then maybe if he wants to leave, he can, right? And we get the benefit of listening to him and learning how they are using OpenFGA. Thank you very much, Massi, for being here, and I will let you share.
Wonderful. I don't know if I can actually, I was looking for the share button. I don't know if I can actually share my screen or.
You should be able to do that, yes. You should have permissions to do it, I think. Let me see. And who can share? All participants.
All right, sorry. It was, let me just do this. Okay, perfect. It was just, I was clicking a button. It was not,
Sounds
was
good.
not working, but hopefully it should be right now. So having said that, so hello everyone. My name is Massi Gori. I am the product manager. I'm a product manager at Canonical for the year of the company that is called Enterprise Engineering. What is it? It's basically everything that has to do with our operator framework and our application operators. But most of my background is in identity management. I was a doctor for a bit as well. And one thing that I sort of wanted to do today was just talking about, where are we using OpenFGA, and a little bit of an intro to and a demo of our Kubernetes operator that we are using inside the company, and then we built with that. There were many things that we can demo. I mean, so maybe one of those other months we can come back and show you like another piece, like the UI that we've built for it, and also explain like what are we planning to build on top of it in Canonical over the past few months. So this is kind of like a slide that we normally use to describe the Canonical infrastructure portfolio. I mean, obviously everyone knows that we make Ubuntu, but in reality there is a lot more than we actually make. We are very active in the like hardware provisioning side with Massi. In the OpenStack community, we are the kind of like biggest provider of commercial OpenStack, for the past couple of years. We have our own like Kubernetes distribution, LXD microcloud, so other virtualization and orchestration elements, and also we provide a set of operators for common open source products like all the Hadoop ecosystem, the databases, and a bunch of other stuff. So, pretty big portfolio. And there is one thing that we decided to basically take a hard look at the way we do identity management and authorization. And basically we found that the RBAC model, that the traditional RBAC model was not sort of like fitting for our current use cases. And that's why we either started or introducing, or we've already introduced OpenFGA as part of many of the products that we ship. We're also using OpenFGA for what we call the contract service. That is the service that manages the Ubuntu Pro entitlement. So if you are if you're a Canonical customer, if you use one of the free tokens that we give away to get extra security patching, chances are that like in the backend at a certain point you also interact with OpenFGA as well. But before that, I wanted to spend a little bit of time talking about like our packaging story. So in general, the reality is that wide Linux distribution, which are fundamentally a kernel and a package manager, if you think of Ubuntu, they serve software delivery needs for a while. I mean, today they're insufficient because of an increase of diversity and complexity of average software deployments. And so, companies might decide to run to deploy applications on bare metal, on Kubernetes, on servers, and in either cases they need to and just say also pack the application code together with that. And in general, like in Canonical, we have this three major main packaging standards. One that is snaps, that are primarily a way to package application and their dependencies for servers or desktop applications. Rocks, that are basically our sort of like version of opinionated Ubuntu distroless container images. And then charms. Charms are like, as we will look in a bit, like packages that like help include the operational code, that attach the operational code to a specific workload. Right now we have created a rock and a charm for OpenFGA, meaning that these are like artifacts that like pull all the latest and greatest from the upstream that like Andres and the team are putting together, but is obviously like security maintained with all the bits and all the dependencies that Canonical creates. And obviously it's, let me just say, free for everyone in this call, or in general, like around the world to use and consume. So the idea for this demo is also to show you a little bit of a demo of what charms are, and maybe we can talk about we can show like OpenFGA in the context of a project in one of the next couple of months. Just wanted to rather than showing like straight like a CLI, I wanted to spend a little bit of time about like Juju and charms and what they are. So fundamentally, I mean, we all know that there is a lot of open source and there's never been like much choice around it, but the reality is that oftentimes like operating it tends to be relatively hard, and there are like many moving pieces because applications like OpenFGA or like any other ones, you don't just deploy them in isolation, but you sort of like tend to run them together with data backends, ingresses, and observability platform, tracing, certificate management, and identity management, and so far and so forth. So the reality is that while it is relatively simple, these days it is relatively simple to deploy an application in production, just making sure that on day 500 or day 1000 it works just as well as on day one. It is sort of like increasingly more complicated if you need to keep like all the connections in sync, do updates, upgrades, and ensure consistency along that stuff. So charms are a way to like open source like all the operational knowledge that comes together with this application. And we in Canonical we use Juju, that is the like orchestrator, sort of like our operator framework that is a way to deploy any application like at any scale, at any platform on or any substrates. And the idea, and I'm also looking at the time, and I'm sort of like blasting through this, but the sort of like tricky things about three main things about Juju is that like in reality it is something that it's not confined to the realm of Kubernetes, but it also works on bare metal machines, on the public clouds, and on the Kubernetes distribution, also on the let me just say like either vanilla K8s or the ones that are available on the three major clouds. So like it works on a variety of multiple targets, and the reality is that you sort of like write this operation code sort of like once, and ideally you can reuse it across all of the different platforms, with Juju sort of like taking care of like the burden of that. There are a couple of primitives, and we consider like application integration as a first-class citizen in our model, and we will look at like what it means also in the context of OpenFGA, meaning that we try to Juju tries to optimize for the life cycle of the system as a whole and not of the individual application. So like it ensures that consistency is maintained also when applications are scaled up and down, they are upgraded, they go down, they recover, and so far and so forth. And it does that not only in a single cloud, but also like across multiple clouds if you so wish, and if your deployment has this sort of need. So I would share the link to this presentation, but you can sort of like see the links to like here our OpenFGA charm and our OpenFGA rock. Those are the links to the GitHub repositories, but you can also find them in the in CharmHub, which is sort of like the web store that we have for this. And in the brief demo that I will show you, what we will do is that we will basically deploy the operator for OpenFGA with Postgres as a backend. Like also there will be like an ingress. This is obviously not necessarily required if you're doing like in cluster communication, but we still have it in there. And on the observability side, I mean, we just to like also show the fact that we haven't just created some sort of like operator for let me just say that the installation and the connection of OpenFGA, but we are also leveraging the concept of integration to automatically create some alert rules and observability dashboards, which are automatically provisioned the moment the OpenFGA is connected with the the applications that you see in that box on the right. I mean, unfortunately, I'm in Italy right now, so my internet connectivity is not the best ever. So I have just prepared this little video, but as I said, like this is a single take, so you can see there is no cheating here. What we're doing in the beginning is like using Juju to deploy the OpenFGA charms, so the OpenFGA operators and the Postgres operator. So you can see that this is the Juju status dashboard. This deploying the charm obviously takes a little bit of time to pull the container and install it. So I'm just gonna skip a little bit while this boring part goes through. And you can see that like eventually both of the applications will come up and they will be active. So what we're doing right now is that we're also deploying all the observability charms, so the observability operators. As I said, like even here, it takes like a little bit of time, a lot, and obviously like a lot more integrations and like units. They are slowly sort of like coming up and connecting to each other, like automatically configuring themselves. And we can also skip ahead. What you can see is that, you know, as the application, as the configuration is sort of like exchanged between the different units, they start from going from idle to blocking to like executing, and eventually they become active, which means that they're good. So after that, after sort of like the deployment is completed, and we'll sort of like continue skipping ahead for a bit. Here, what I'm saying, what we're showing is that we are logging into the Grafana dashboard, and we wanted to show you some of the like alert rules that are created, and that's what is going to happen right now. So some of them are sort of like already there. We are planning to like further like announce that and like add additional one. And also, if we sort of like go like a little bit ahead, this is the example like of a dashboard that also comes, let me just say, for free the moment you sort of like integrate it to application. One thing that I want to mention is that with Juju, or with our operator framework, Juju is not the proxy by which like all the connection like are mediated. So like the application, they talk directly to each other. But the thing that it does is that it obviously keeps like track of the state of the system, and it sort of like mediates the exchange of the configuration parameters between the different applications. What we are doing in the, let me just say, final part of the video is just showing that like everything works. So we're going to import like a couple of tuples, make some API requests, and basically show that they are actually visible in the Grafana dashboard. So what you're seeing here is that we are effectively like scaling up OpenFGA. We're adding a couple of more units, a couple of more pods, so bringing it from 1 to 3. And yeah, so after that we are going to anyway just show that there's some tuples, and then we're gonna just make an API request to the OpenFGA server. So you're probably already familiar with this, but just to kind of like show that like everything is works the way it should. So I can potentially skip forward to this. So first of all, let me actually say like why are we doing this? So in Canonical, everything that we do is based on one of the 3 sort of like packaging formats that I said before. We do not deploy or like operate like our internal IT or our customers. They do not deploy or operate applications that are not packaged together with the required operator code. So whenever we go and do a deployment, that is usually facilitated by Juju, and it normally like pulls, as I said, like one of those distroless security maintained, canonical security maintained container images, or it pulls from a snap, depending on whether it's it's an operator for virtual machines or for Kubernetes. We are working to include OpenFGA as the default authorization backend for all of our applications that are MAS, that is the canonical product for bare metal server automation for LXD. You can think of it as a, if you're not familiar with it, just think of it as VMware, but like a mini version of ESXi that also that works with VMs and Linux containers. Also Juju itself, like the permission management will be done using OpenFGA itself. So we've been busy recreating our permission models to become more granular and more like attuned to the reback. Let me just say to the way you would express it in Reback. We've also created a permission management UI, which actually you will firstly see it in the next release of LXD. So LXD 5.2.1 has been released 2 weeks ago. Like it includes OpenFGA backend. The UI, the LXD UI doesn't include like all the things that all the sort of like new way for interacting with the backend, but like you definitely can from the CLI. This is planned for the next release. We just missed it 2 weeks ago because of some QA bugs, but ideally we can show it again in one of the next meetings. We are planning mass integration at the end of 24/10. I mean, we plan the work in 6 months cycles, as you can imagine, like kind of like following a little bit of the Ubuntu releases. I mean, we haven't really planned for it, but if there is enough demand, I guess we can consider either like doing it ourselves or working with some of the other like community members or you know the people from Okta to create a snap package for like either the server or the SDK that comes together with OpenFGA. So I guess that's it for me. I tried to squeeze it in the 10 minutes that we discussed with Andres. I know it was a lot, and of course we can talk a lot more about it. But the key thing that I wanted to stress is that the product is going to be it will be instrumental for the canonical like permission and authorization strategy, and we are sort of like trying to, as a company, to align around that. Any questions? I saw that there were some comments in the chat, but I did not. Yeah, Juju. Well, I mean, it's not like Helm. Like it goes a little bit further than Helm in the sense that it like. As I said, it doesn't only target Kubernetes, and it also includes, I mean, let me just say, the ability to express integrations in a much richer way that Helm doesn't do. It also includes, I didn't show them in this demo, but it also includes things like actions, which are a way to kind of like condense very boring administrative tasks that normally will require you a lot of clicks in like a single command that you can sort of like execute directly from the CLI. I mean, all of this right now we showed it with the CLI. We also have a Terraform provider for Juju, so like obviously this also works with that. If you have a larger deployment or any sort of like the need for a more automated CI use case. And yeah, that's it for me.
Thank you very much, Massi. Very, very exciting work. And we are really happy that you were able to successfully integrate OpenFGA across the canonical stack. It's very awesome. So thanks for doing it and for your help in the community. So. Okay, good. So next we have another demo, which is the demo for Modular Models, which is the feature we're going to ship tomorrow or the day after tomorrow. The day after tomorrow is Sunday, so Saturday is probably on Monday, if not. But anyway, so I don't know who's going to demo it. If it's, but just feel free to share your screen. I think it's Ewan or yeah. Just share your screen and go ahead.
Okay, so I'm just going to do a quick run through. We kind of chatted bit more in depth about the hows and whys. We're not going to chat about that today. And after I finish presenting, I'll share some links to the docs and the blog in the chat. So modular models is taking a single model file, and splitting it across multiple different files. We've kind of integrated that into VS Code. So for example, if I rename my organization admin here, you can see that it kind of highlights in the FGA mod file, which is our package project info file, I guess, for lack of a better term. And we kind of also then track these errors across the different files. It supports things like the tests that are already supported. So you can see I have my store.fga. Again, that's telling me that I broke something. My store.fga here references the fga.mod, so that's supported. And then my tests work as they would with a single file. And then there's one more thing that I wanted to show, which is I think since we last spoke, we've added this kind of comments. So for areas that don't support modular models yet, such as like the playground, to kind of represent where types, relations, and conditions have originated from, we'll add these comments into the FGA file when it's transformed into a singular DSL, and that kind of like annotate the module and the file name. So yeah, kind of super quick demo, but hopefully it was going to end with it's shipped. If it's not shipped yet, it will ship soon. But yeah, that's kind of it. Really.
So the idea there is just to maybe you can show each. So the idea here is you have a conceptual model, right, that is split in several files. And can you show a little more each of the files? So we have the core FGA file, right?
Yeah, exactly. So we've got core.fga here, which is kind of maybe your top level user and organizations that are shared across an organization. And then reused. The kind of example we're tending to use is like a Jira style example, a Latticean and a Jira and a wiki. So they have, for example, core types, which are user and organization, and then, for example, projects, which is maybe your Jira project that can extend different types. So organization extends, projects extends organization with can create project, because that's not necessarily something that is needed in the top level organization type. And then again, kind of adding its own type here with project. Yeah.
And then you also have the wiki one, the wiki one will be the equivalent of Confluence there, right?
Yeah.
Okay, so that you also have the types.
Yeah,
so the idea
again,
here
that
is that
can create space.
The goal of the feature is that each team, in this case, the team that manages the wiki or manages the issue tracker, will own their own models, right? So given that authorization is application specific, you want each team to own a piece of the authorization model. They will have their own code owners in GitHub or whatever equivalent in your source control platform to make sure only that team can approve PRs on that file, so they own that piece of the model. But conceptually, they are joined in a single model that works as a whole, right? So the idea is to enable larger teams to collaborate in a single FGA project by splitting modules and ownership across different teams. That is the goal of the feature, and that's where we're shipping soon. And that implies shipping, we had to change everything, like for the Visual Studio Code integration, the CLI, the server, the SDKs to expose this in the right way. And then, yes, so perfect, yes. And then let me see some questions there. Maybe the way for modular permissions, yes, we are gonna discuss that later. And then deterministic ordering of the various modules, no, but yes, if you have the same type in two modules, whenever you try to join them together, you'll get an error, right? So we had a conversation at some moment about should we namespace the modules somehow so that you cannot have conflicts between types. But the issue is that if you namespace the modules, the namespace ends up changing the type of the tuple, right? That implies that if you want to move one type to another module, it implies migrating tuples, right? And migrating tuples is expensive. So we decided we don't namespace anything. we join them in a single model. If there are duplications, that joining the model fails, right? If you want to have the same type in multiple models, you can namespace them themselves. Conditions across several modules, yes, you can reference them across several modules.
Yeah, conditions can be written across multiple. It's just that they don't fit into this example. Or at least when I was writing it, I couldn't think of any obvious conditions to write. So we'll try and add that as an example too.
Great.
Awesome.
So next in the line is we have a demo of the work we're doing on ListUsers. I think Will has recorded one there. He might want to share.
Yeah. Hi, everyone. I'm Will. I'm an engineer on the FGA team. I did want to show a slide that we had in the last community meeting that just to kind of prime the concept of ListUsers. It's a new API, and it answers the question of what users are related to a specific document. So on the right, you'll see a Google Share dialog, and that's just one of the few use cases that this will help solve. So that's one use case. So like a share dialog, so you can see the users or groups or user sets that are associated with a specific document. But it also could be useful to help notify users if a document is edited or if a document is deleted. So you can potentially send an email or send a notification or what have you. We did publish an RFC. I think you can still provide feedback, but we as a team have been working pretty hard on this so far for the last couple months. So let me stop sharing my screen for a second and get to the demo. I am not as daring as some other people, so I just recorded a video, but I can, we can do some like live demo if that's requested. So.
Well, we cannot hear the audio. I think you need to also share audio.
Oh, you can't hear
Or you
the
might
audio.
you can also speak over the video if you want, and just that will work too.
Sure. I'll speak over the video instead, so I can confirm that you can still hear me. Okay. So ListUsers is enabled with the experimental flags. So here, when you run the OpenFGA server, you can pass enable ListUsers into the experimentals flag to enable. Otherwise, it will not, that endpoint won't be accessible. But it fails because I have another instance of OpenFGA running over here. Just did a little bit of setup for this demo. First of all, I created a store. And I also created two models that correlate with these two examples up here. So I also have this cheat sheet that'll help me speed along the demo a little bit. So just starting off with a first call, we introduced this list demos endpoint. This payload should look pretty familiar for most of the developers. We accept an authorization ID. We offer require an object type, a target object rather, with a type and an ID. We have a target relation. So you have to specify the relation of the object that you're specifying. But we also introduced the concept of user filters, which is the terminal type of the subject that you're attempting to target. So in this case, user is the only terminal type that pertains to the viewer relation on document. But you do have the flexibility to specify others as well. And we'll get into that later in the demo. So if we run this, you'll see that there are 0 results here, and that's because there are no tuples in the system. So for the simplicity of this demo, I'm just using contextual tuples. So we're going to grab a request with some contextual tuples in there, and you'll see that these tuples correlate to these tuples above. So user John and Maria are associated with document 1 as a viewer, and then user will is associated to the viewer relation on document 2. And those are expressed as contextual tuples in the request. So what we would expect is that user John and user Maria are returned because those are the only users associated with document 1. And just for completeness, if we change this to document 2, you'll see that user will is returned as expected. So getting into a little bit more of a complex example, we introduced the group type, which has a member relation of user. And then we've also changed the terminal type we added the group member user set as a terminal type on the document viewer in addition to user. So a little bit different of example. And so we have these tuples down here. User Maria is directly related to document 1 as a viewer. But now we introduce group engineering, and we say that the group engineering user set is associated with document 1. And then we added user Sergio and user Maria as members to that engineering group. And just to make it a bit spicier of a, and one thing I note here is that user Maria is both a member of group engineering as well as directly related to document 1. So that is a possibility here. And to make this example a bit spicier, we added the group product who Andres is a member of. So if we run ListUsers with this example, you'll see that these tuples correlate to the tuples in the example above. And we target document 1, and we target the user filter instead of the group member user set. So we expect to have users returned. And when we run it, that's what we get. One thing to note is that user Maria is associated twice to this document, but she is only returned once in the ListUsers response. You'll see that Sergio is also returned because he is a member of the engineering group, as well as Andres, who is a member of the product group. So the user expansion or the request expands to those terminal users. And so going to a different example now, which is a bit more of an interesting case, is we introduce, it's the same request. However, this time we are looking at the group member user set instead of targeting users as the user filter. So we expect to get group member user sets returned in the response. And in here we have two two groups, the engineering group and the product group. But it's important to note that users will not be returned here. And that's what we get. We get the engineering group members and group product members. So this kind of lends itself nicely to the Google Share dialog, where you can target users who are directly or indirectly related to a document, but as well as groups, or you can think of it as like organization or whatever your hierarchy is. And so ListUsers can get a lot more complicated from here, but this is just a general overview and just should serve as a starting point for demonstrating the capabilities of the endpoint.
There's a question there. If we are able to ask for two different user types when you call these users, so the return users and group members, and also if we support two different relationships in the same request.
It's a really good question. For this experimental release, we've constrained that user filter to just one for now, but we see the need of it to expand. Okay. So we anticipate adding more as time goes on. In terms of multiple relations, I don't think that's something that we are looking to support. But it's if the use case warrants it, we can certainly consider it.
Okay. Perfect, thank you. So we have another demo and then a conversation. We are running out of time, so we are going to do it anyway. And so the meeting will gonna last a few more minutes. If you cannot stay, need to leave, that's fine. The meeting will be recorded and you can watch the demos later. Okay? John, is your turn now if you want to demo. All right, so the last meeting, we demoed an integration with a product called Materialize to try to help solving the search with permissions problem. Jonathan kept working on that. We're gonna share where we are with that effort right now.
Thanks, Andres. So I don't know if you guys, the community, have come across this document on our official doc site yet, but there's this problem in fine-grained optimization that we describe as search with permissions. The idea is some use cases will arise where you need to apply a data filter to some query in your application. But you also need to join that with a permission filter that is coming from OpenFGA. And when I say join, I mean like a native database join, because if you have really large data sets that you're filtering and you have really, really large permission, a really large permission filter, you need to be able to join those with whatever database technology you're using in order to serve that use case efficiently. So the body of work that we are working on right now is what we're calling the FGA indexer. And we are trying to bring the OpenFGA permission graph to the client so that you can use that information client side quickly with native database joins. So you can solve this search with permissions problem. There's a product called Materialize, and we are collaborating with them to help us solve this problem. What we're going to be doing, I can just kind of jump in at this point. Given an FGA model, we're going to convert this model to a materialized view. So given this model, we can programmatically produce a materialized view that represents the FGA permission graph. And when I say this materialized view, essentially we're flattening the graph. So you can imagine all of these relationships. You can view a document if you can view it or if you can view its parent. Can view is defined as viewer, but not restricted. So if you're restricted, you cannot have the can view relationship. Group members can be related to users or other groups. So you can have nested groups, you can have hierarchical folders, and you can have all of these complex rules. We're going to take all of those rules, we're going to compile them, if you will, to a materialized view statement, and we will flatten the FGA permission graph for you so that you can then join against that table and solve that search with permission problem in a really efficient way. So given an FGA model like this, we will produce, I don't expect you to understand this or read this, but we will produce this create, view statement or a materialized view statement. And this is the definitive SQL, if you will, that represents the FGA model. Given that, you can then create a materialized view off of it, or you can just create a view off of it and you can join with this table, FGA index, to solve that search with permissions problem super efficiently. Now, how does Materialize come into the picture here? Well, what Materialize is really good at is computing, very efficiently computing incremental changes to relational data just based on the change set. So in materialized views, you can imagine the FGA permission graph has a lot of subgraphs involved, right? When I say subgraphs, going back to our model, you can imagine you can view a document if you're a viewer on it, or you can view its parent. And you can view its parent if there's a hierarchy involved there. So you can have parents of parents and so on and so forth. Those all define these subgraphs. And what you want to do, ideally, is only recompute the changed subgraphs as a result of a single FGA tuple change. If you have to recompute the whole permission graph every single time a single tuple changes, that's going to be an extremely expensive operation and not an efficient and scalable solution. So what Materialize does really well is they determine what subgraphs have changed in these materialized views, and they only recompute the changed subgraphs. The way that they do this is they keep a reachability graph of the various tables and columns that are being selected from that are involved in your materialized view. So they can super efficiently compute just the change set, not the whole permission graph. So that's why we're using them. to help solve this problem. So let me go ahead and jump in here. Again, given this model, we can run a utility. Right now, we're thinking about this as being a CLI. This is kind of experimental right now, but you would use a CLI and you'd call like generate index. You'd give it your FGA model, the file for that. You give it a name. So just like in a regular database, you can create index and you give it a name and then you choose what columns you want to index. You're going to give this FGA permission index a name, and then you can tell it where to put the output. The output is the SQL definition. So we'll go ahead and run that. And then down here in these two windows, I have Postgres running and I have Materialize running. Postgres is simulating the database that is sitting behind OpenFGA. So I'm not using the OpenFGA API yet. Everything I'm going to do here is simulating writing tuples and deleting tuples as though they were happening through the API, but I'm just going to use the database directly. So down here in Materialize, we can go ahead and we can create that index or that, the FGA index, the permission index, and that creates this view. We can select from that view just like it's a table, right? And this view will define the flattened permission graph for the whole FGA permissions. In this case, there are none in the graph yet. The permission graph is empty. There are no tuples. If we go up here, select all from tuples, there are no tuples yet. So let's go ahead and create some tuples. Now, the tuples we're going to create, bear with me here for a second, but we're going to create some nested groups and we're going to create some hierarchical folders and documents. And then we're going to write these in and we're going to show that we follow all of these nested, deeply nested and widely nested sets in order to flatten this permission graph. So here we're going to add user John as a member of the FGA backend group. That's this first tuple. The FGA backend group is part of the FGA group. And the FGA group is part of the engineering group. So you have this, nested FGA backend, FGA, and then ENG. We're going to give the viewer permission to anyone who's a member of the engineering group. And we're going to give that on document 1. So because user John is indirectly through this, hierarchy related to the engineering group, user John should have access to document 1. Then we're going to show a hierarchy, a document in folder hierarchy. So folder X is the parent of document 2, and folder X has a parent of folder Y. So folder Y is the top of the hierarchy, folder X, and then the document sits underneath that. And we're going to give Andres access to the topmost folder, folder Y. So Andres has access at the highest level in the hierarchy. Let's go ahead and create these tuples. All right, so we inserted 7 tuples, and then we can go down here and we can ask our index, I want to know all of the users who can view documents. And if we go back to our model, can view is defined as viewer, but not restricted. So notice we're following unions, we're following exclusions, and we're also following nested hierarchies. Let's go ahead and make that query. You can see that we get 2 outputs. John can view document 1 and Andres can view document 2. So we followed those nested hierarchies. We followed those nested groups, and then we flattened that and given you an output that represents the effective permission graph here for users related to documents. Let's go ahead and spice things up a little bit. Let's say that we want to blacklist user John. So we're going to revoke user John's access by inserting a single tuple, the restricted tuple. So remember, can view is only true if restricted, if the user is not explicitly restricted. So we'll go ahead and we will write that tuple. And then we'll go down here and we'll ask for those relationships again. Notice user John dropped off the list. So user John is now explicitly restricted, and that index now reflects that new change. So the reason I demonstrated that is because it shows you that we're also supporting these more complex rules involving intersection and exclusion and those things. Let's go back to our tuples. So we're gonna delete that tuple that we just inserted. So that should reintroduce access for user John. We can go back down here. We can delegate. So user John shows back up there. That's great. Now we're going to spice it up a little bit even more. So we're going to delete we're going to remove the FGA group as a nested group of the engineering group. So John's a member of the backend FGA group. The FGA group's a member of the engineering group. And we're going to remove the intermediate nested group. So we'll go ahead and delete that tuple. And then we can select from that index again. Again, you can see user John drops off. So we're following those nested those nested groups. And when that intermediate nested group goes away, one single tuple change, it impacts the index. Similarly, and kind of to wrap things up, I'm going to go ahead and remove Andres from that viewer access on that parent folder. So folder Y is the topmost folder in the hierarchy. You remove Andres's access at the topmost level in the hierarchy, it will remove Andres's access to document 2. So we'll go ahead and delete that tuple. And then we can select from our index again now. Our index is back to being empty. So given this index, what I'm showing down here, selecting from this index, this becomes the table. The table in this case is called the FGA index. This becomes the table that you could use to join against your primary data table when you're doing search use cases and you need an efficient access aware filter. This is described more in option 2 in our official docs. We've made a lot of progress on this MVP, and I think this approach is very, very viable. And using a product like Materialize makes it very efficient and a good approach in general. So kind of next steps for this work is we're going to be shipping some kind of official tool, utility, maybe an API, to produce these Materialize view statements given your FGA model. And once we ship that, that will correspond with some documentation on how to build these indexes and some architectural best practices and things for how to use these indexes. Our goal is to deliver this feature to the community in incremental steps so that you guys can start building these things as soon as possible. And eventually, we would like to see this as a native feature of OpenFGA's API and of Okta FGA, our SaaS offering. Basically, FGA indexes as a service kind of style of offering in the future. So that's kind of the direction we're going and the work that's been done, and love to answer any questions.
And so a question, John, in the Materialize view, what you're showing there is data that is being written to SQL, to Postgres 2? Or so what's the database that Materialize is using to materialize those views?
Yeah, so you have Materialize basically watches for CDC off of a database. So in this case, we have Postgres. Tuples are being written into Postgres. Materialize is watching CDC on that and then producing the Materialize views off of the write ahead log coming off of Postgres. Yeah.
And the Materialize view is written to a Postgres table.
Yes, correct. Yes.
Okay. So both windows are actually talking to Postgres, right?
Yes.
It's just that one is using Materialize as the way the queries that you're running in the Materialize window, you can also run them in the Postgres window, right? Because those tables exist. Okay.
In my example here, I just created a view, but you could create a materialized view as well. And in which case you could select off of that from whatever the database is that's actually storing that. Yes. Yeah.
So Carlos, have a question.
I wrote it down, but the question was, I guess I'm having trouble visualizing this, but Materialize as the application that's creating the view would have to have access to all source databases, those same source databases that push data to OpenFGA. Is that how that works?
In this
we
case,
only need to have access to the tuples table of OpenFGA.
Yeah.
So you're using the tuples table of OpenFGA as the source to then create the index table.
Yeah.
Yes.
Okay. So you're eventually consistent in OpenFGA, which then makes you eventually consistent on the index because you're chaining those.
Yes. Yeah, OpenFGA, you can run it in eventually consistent with strong consistency depending on how you configure the cache. But yes, that is it.
All right.
The tuples table, this may not have been clear, but the tuples table is just direct relationships in the graph. And so what we're producing is we're following all of the computed or the rules in the model. So given just the direct tuples, we're computing the subgraphs based on the model. So the output of this index can be quadratic in the input size, which is also something that's important. Is when you're building these indexes, just like in a database, you're not going to index everything because you don't need to index everything. You only need to index what your primary query patterns are targeting. Similarly, you're not going to create FGA indexes for everything. You're only going to create FGA indexes for the relationships that you need to serve efficiently with these indexes. So for example, Google Docs, you have the search bar and you can search for documents. You probably only need an index on document viewer for user subject types, because the user's logging in, they're searching, and then they want to see all of the things that they can view and that match the search criteria. You only need an index on viewer there. So those kinds of considerations are going to be important best practices and architectural kind of guidelines for how to use this tool. I see some questions. I'll just kind of start one by one and go down.
I'm running late to another call, so I will let Ragged wrap up the meeting. And thank you very much for your help. See you again in a month.
Yep. So Andrew asked, will this index require an integration with Materialize, or will its functionality be fully integrated into OpenFGA? So for now, our thinking is that different SQL dialects support recursive queries. So the whole underpinning behind this work is recursive common table expressions. And so different dialects of SQL support different semantics on those recursive common table expressions. We can support, for some FGA models, we can support creating these recursive CTEs in other dialects like Postgres and MySQL. But there are limitations for the recursive CTE definitions in those languages. And there's also other considerations, such as when you're creating materialized views in Postgres or in MySQL, you have to do manual refreshes. So you don't get automatic, like real-time continuous updates of your materializations with technologies like Postgres and MySQL. So in some cases, and if you trigger an automatic refresh, if you trigger a manual refresh, it locks the index table during that window of time as well. So there are other impacts to different implementations of materialized views have different side effects. Some may work for your use cases, some may not. If you want to roll this work out, we're going to be producing recursive CTEs as best as we can across a variety of dialects. So you don't necessarily have to use Materialize. But I will say that Materialize, at least right now, based on current support out there in the industry, Materialize is going to be the most efficient way to handle this because of the incremental updates on these materialized views. And as far as integrating this into OpenFGA, that's what I was mentioning. In the future, we might expose APIs around creating these indexes, and then theoretically OpenFGA would manage the index. It's really hard to imagine what that would look like if we're depending on a commercial SaaS product, Materialize. So I don't know what that looks like right now, but just like a database has an API to create indexes, I think it makes sense at some point in OpenFGA's future to have an API to manage indexes as well. Don't know what that looks like yet, but that's kind of the vision.
Just a quick note also. So in general, yes, but what John said, you will need Materialize to get proper like incremental updates at scale. You don't want to lock your table. Now, if you have a case where your tuples are not changing that much for one reason or another, like you can handle things, just don't change a lot, you may be able to do manual refreshes at like some downtime, where your app is not being used. Of course, that's not the best experience, but yeah.
Carlos, I also see you asked to reiterate the difference between the Postgres window and the Materialize window. So here's our thinking there. Basically, the concern may be that your index may lag behind your actual tuples, the tuples in your primary OpenFGA database. So there's this concern of staleness between what a check or a list objects or something might serve from the API versus what the index reflects at any moment in time. Something that we're looking at actively right now is we're kind of looking at this problem more holistically. We recognize that there are usage patterns of OpenFGA where the client wants to enforce stronger read consistency on their queries. So part of that body of work kind of informs some of the design decisions around this indexer work that we're working on. The idea is that every insert or delete into OpenFGA in the near future may end up being like append-only log semantics. So every insert or delete creates a new revision, and you have a snapshot revision at any moment in time, right? So you can serve a check no staler than a particular snapshot in time. Similarly, your index is watching the tuple changes, CDC off of these tuple changes. So your index can have a notion of revision history as well. You can say this index was produced and is accurate up to this revision or snapshot in time. So if you're selecting from the index, you can select from that index as of a particular snapshot, no staler than a particular snapshot. Just like you could serve a check or a list objects, no staler than a particular snapshot in our core API. So using that mechanism, you could ensure that if you're reading from the index, you're reading an index projection that is no staler than what you're querying from in OpenFGA as well. So that is what I just described there. You know, we don't have support for stronger read consistency semantics natively as part of the API in OpenFGA today. If you deploy OpenFGA with a single Postgres backing it, you're going to get strong consistency. But as soon as you scale that across regions, it's not necessarily guaranteed. That's the problem that we're trying to more generally solve sometime this year. And as we do this indexer work as well, we will be able to serve, you know, stronger consistency reads from the index as well, based on that same kind of pattern. Does that answer your question though, Carlos?
Yeah. Yes. I mean, I started off with just the simpler question of, because that I saw that it was two tables, Postgres and Materialize. And so I was curious, what the difference between those two were. Are they supposed to simulate two different databases, like Materialize being I guess that was the other part. Materialize is intended to be the target database that's doing those joins, right? So if it could be in essence some source database of some authorization tuples, maybe not all of them, because you have effectively like a fan in from source databases into OpenFGA, and then that gets denormalized by Materialize back into some of these source databases so that they can do authorization decisions. Is that correct?
So OpenFGA writes to Postgres. Postgres gets CDC imported into Materialize, and then whatever you're doing search with in your application. So you have some database table in your own application stack. It might be in MySQL, might be in Postgres, might be in Dynamo, Elasticsearch, who knows, right? Materialize is doing the compute and the flattening of the index. And then you would be CDC sourcing the output of that materialization to whatever your application database is that you're doing search with. So let's take MySQL as an example. Your application's written using MySQL, and you are doing search using MySQL, for example. So you would take the output from Materialize, and you would source that into your MySQL, and then you can do native joins in MySQL with whatever your application data is that you're doing search filtering on. Does that make sense?
Yeah, that makes sense. I was just saying, in the scenario where you have, let's say, 4 databases, you have your permission system, maybe you have some tenant management data or organizational data, however you want to describe it, and then you have an entitlement system, all of which have different databases. All of those are feeding into OpenFGA in an asynchronous fashion, ideally, right? So that's what I was calling the fan in into OpenFGA. From OpenFGA, you're then using Materialize to denormalize that data, flatten it, back into one or more of those source databases so that they can do joins against that data when they do searches.
Yep, exactly.
So Materialize is handling the translation from the tuple data to the target schema type or provider type.
Yeah, the direct tuples to the denormalized FGA permission index, and then to whatever downstream application databases. Yep.
So if that was like a NoSQL, like Mongo, for instance, it would handle that translation.
Well, so you would be in charge of providing the source, the CDC sourcing to your downstream. So, you would, in reality, you'd probably have an architecture where Materialize sources the output of the index to Kafka, you consume from Kafka, and then you write it out to all of your application databases as needed.
Okay.
Yep.
Now,
and in general, what you're going to be joining on are your primary keys, your object identifiers, and those things. Yep.
That picture is clearer now. I appreciate it.
Yep. Mohan asked, am I correct to think this cannot be used if there are conditional tuples in place? I'm actively working on that. So if you can convert a CEL expression to a SQL query, to a SQL predicate of some form, then we can support conditional relationship tuples. And I have some examples of that working. It's not complete enough yet. I didn't feel it was worth demoing today. But the short answer is there are some CEL expressions that we for sure can support in this indexing work.
That would be great. Thanks, John.
Yep.
Vigor had his hand up.
Thanks. Would we be able to use this feature to spit out all the groups that have access to the doc instead of the users?
Yeah, absolutely.
Perfect.
So in my example, when we were selecting from the FGA index, the materialization, I was filtering by subject type equals user, but you could filter by subject type equals group. And there you go. That's all the groups.
Just like a 10-second context, why we'd be interested in this is because we want to pump this to our Elasticsearch index, and we can't put all the users because for our SaaS customers, they could be in millions of users, so we can't put that list into the index.
Exactly. Yep, that's a perfect use case for search with permissions, and that's why we're building this. So in this case, you would consume the CDC off of this stream and put that in Elastic, and then you've got an efficient filter that you can apply.
And until we roll this out, you can also use ListUsers. So ListUsers works the same way. You can specify the user filter being a group. So instead of being the user, and it will also return this list of groups.
True, but it wouldn't be as efficient as this materialized view and at scale. We'll be doing incremental, just for more context.
Yeah, definitely not, but it'll be available earlier.
Yeah.
Naveen?
Yeah, hi. I think it's been a couple of years, 2 years basically, before when we were exploring. You helped me out a lot, and I'm back at it again. I'm sorry I missed the first part of the conversation as I just saw the Slack message. So my question is similar to what I asked on the channel itself. Is the intersect operation, is that achievable through the modeling language? Because we have a specific use case where if user is part of 2 orgs, and then if a document is part of 2 orgs, only then allow that user, that it has to match. So is that scenario possible using the modeling language?
Yeah, you can have a user multiple orgs, but in general, you want to have a user, like when you're authenticating, when you're checking for access, when you're authorizing, when you're checking for access, what you can do is use something like contextual tuples to say what context the user is in right now. So if they're switching, they're probably viewing within a context of one org, not the other. So what you can do is send us another contextual tuple that says, okay, the current org in context is org A, and we have some documentation around this we can share.
Okay. Yeah, I'm taking an example of org here just to make it easy, but imagine this as a tag basically, right? They could have like 4 or 5 tags, the user, and the document also can have 4 or 5 tags. Only if they all match, user and the doc matches those tags, then the user gets access to the doc, something like that.
That would be a bit more that will basically, the answer will depend on how you're thinking about it. Conditions in that case might work. Depending on how much you need, they might not be a workable solution for you, but that's where actually they can come in. So you'd say, okay, someone has access when you're writing the tuple, like you'd say with condition X, and you would have to pass in the tags, of course, as context. So you wouldn't have them. You would send them as part of your check query. Some of them would be safe. So the ones related to the, for example, to the document, you might save them. But it's better to send in this case, because they might change, send them all as part of the check query, and it will authorize based on that. But depending on how complicated or how more complicated your permissions get, you might reach a point where this is not workable, but we can definitely work with you on finding those cases.
Cool, thank you. Yeah, I think I'm gonna try that, what you mentioned, like the conditions stuff, and then the check time, send in those tags to see that works. Thanks.
Thank you. If we don't have any questions, we're gonna go quickly through the rest of the not gonna spend so much time. A lot of you have been here for too long, but just what we're working on next is we're gonna add like telemetry tracing and logs to our SDKs, and we'd love feedback from you all as we start. So if you're interested, if this is a use case you would want, let us know what metrics you would want us to expose. For example, we would definitely expose number of like 400s, 200s, how many times you're being rate limited, latency per request. But if there's other things you would want, do let us know. And very soon we're going to start on JetBrains IDE integration. Initial phase, it will not be as feature complete as our VS Code, all the work you've seen so far, but initial will be syntax highlighting, maybe a bit of validation. We're not sure if we're going to support modular modules all the way, but at least the basics will be there. We're also going to investigate additional authorization options, which is sort of like FGA on FGA. Have FGA use, like have OpenFGA use OpenFGA to authorize itself. And this would tie into the modular modules work that Ewan has demoed. So you can say, this API key can write tuples of this type, of this module, like this API can not. And another thing coming up is additional consistency options. We're not sure, we're not going to go strong consistency, but allowing you to say, okay, I'm okay with something being very stale. I know it hasn't changed in a while, and versus saying, oh no, please try to reduce latent or reduce eventual consistency as much as possible. So we're investigating what we can do in that front. So also let me share my desktop just for this feature. For the FGA on FGA, sorry, looking for it. Okay, so what we're thinking, this was what could possibly happen, is we'll be able to specify an application, a module, and a store. Like that's what the internal authorization model for OpenFGA would be. And you would be able to specify writers based on like at the store level or at the module level, like same for readers, same for module writers. And right now we're only thinking of these 3 roles. At some point we'll expand it depending on how we see people using it. But the idea is you may have like these 4 different apps, in this case, Confluence, Jira, and all of these. Each one will have like you can say, okay, this application can write this only this to this particular module. What happens is when you're trying to call check, you will say, okay, the IAM application can write to the core module. But for example, the Confluence cannot write to the issue tracker. It cannot write tuples that target the issue tracker, it's a different module. Again, not gonna go too much into details, but this will help you basically try to have, if you don't want to have a single application being able to do everything, this is where we're headed. We're fine-grained authorization, so it makes sense to go down this route. Finally, we're working on a hackathon internally next week, and if that's something any of you would be interested in, let us know. There may be a chance to collaborate. So right now we're working on these 6 different projects. There may be more, so each one on the team is like picking something and working through it. But so pluggable storage adapters, we've seen a lot, especially recently, people have asked for SQLite, MySQL Server, what's it called? Sorry, SQL Server, the Microsoft one, Spanner, support for Mongo. So, and instead of us having all that built into the core, we would like to have a more exposed adapter, so other folks can maintain their own adapters. In community news, we have an incubation coming up. Not coming up. We're proposed to go from the sandbox stage to the incubation stage. No updates on this yet, but hopefully OpenFGA will reach incubation soon, and maybe graduation soon after. John and Andres were at KubeCon. They had a lot of demos and a lot of good feedback, especially about John's demo on federated IAM with Kubernetes and Keycloak. So do check that out. The slides will be in the meeting notes. We're gonna be in Devox. Sorry, Pauline and Geoffrey from Agicap are gonna be talking about OpenFGA and their integration, how they use OpenFGA at Devox France. We're moving to CNCF. So if you're still using Discord, please join our CNCF channel. And we've already gone through the QA, and we're already way over time. So thank you all for staying with us. All right.
Thanks.